Hey guys, this is your Uniform Motion Part 2 study guide. So the first thing we're going to do is review calculating speed. And I went ahead and put your triangle on there to help you. So remember that should be with the distance in the top. Don't forget your dividing symbols and your multiplication. So that'll help you fill out this question right here. So writing the formulas, whatever you're trying to find, so in this case we're trying to find speed, so you cover that up with your finger, and it's going to be distance divided by time. That's all you have to put to solve for distance. Speed times time. And to solve for time, distance divided by speed. So then in order to do these word problems, you're going to do your guess method. So given, unknown, equation, substitute, solve. So for given, I find whatever they've given me within the question. So 23 meters and 54 seconds. So 23.7 meters is my distance, and 54 seconds is a time. So I went ahead and have those. So the thing out of my triangle that I don't know is speed, which means I'm going to use this equation right here. So I just go ahead and fill that in. Then I just substitute my numbers in. So I'm going to take like this. And when I did that math, it came out to 0.4, and then I went back to look at my units. It's going to be meters per second. So I did the same procedure down here. I wrote down what I was given in the question, 75 miles an hour in 24 hours. So what I didn't know was a distance. I didn't have a unit of distance. So I'm going to take speed times time, just like this, and I end up with 1800. And since I'm looking for distance, I need to find a unit for distance. So I have miles per hour and hours. And the only unit for distance out of those is miles. So that'd be my answer. So I've done the same thing here. I wrote down what I was given, 115 miles an hour and 0.25 miles. And it asked me how long, so I know I'm looking for time. And I solved for time by taking distance divided by speed. And so my distance was 0.25 and my speed was 115, so don't make that mistake. And then I got this answer, which is kind of strange, 0.002. But then I got to thinking about it, and it's asking how long it would take a car that's traveling 115 miles an hour, which is really fast, to travel 1/4 of a mile. 0.002 seconds makes quite a bit of sense. So you can think about it that way, common sense. Question number 6 asks us, what is velocity and how is it different from speed? Well, you can answer that with one simple statement. Velocity is speed, but with direction. That's the important part. That's how it's different. And then for number 7, we're comparing cyclist A with cyclist B. And the first question is at 14 seconds, which cyclist traveled the furthest from 0? Well, just go to 14 seconds and put a little dot there, wherever the cyclist was, and follow it over. And I see this one traveled between 8 and 9 meters from 0, while this one traveled between 7 and 8 meters from 0. So cyclist A, and how did I know? I looked at the graph. And then second question, do the two cyclists ever go the same speed, and how do you know? Well, since this one starts at 0 while this one doesn't, we can't compare the steepness, so we have to actually calculate their speeds, which we can do. Well, here, in case you couldn't tell by the steepness of the lines, cyclist A is definitely going faster, and I went ahead and calculated the slope to see what his speed actually was using rise over run because it starts at 0, while cyclist B didn't start at 0, so I had to use this equation. And when I calculated it, I came up with 0.3 for them. So do the two cyclists ever go the same speed? Well, it's a constant speed, so whatever speed I calculated, that's the speed they're going the whole time. That's the definition of constant speed. So the answer to that question is going to be no, they do not. How do I know? Calculated it. And then this says, do you think one cyclist ever passes the other? Well, there's an easy way to find out. If I just kind of think about moving this line onto the same graph with this one, I just kind of drew it in, which is not straight, but that's okay. It's pretty close. I can see that this one, of course, was going faster. We learned that from this question. And so if they start at the same time, right here where the lines cross, that means that this one is passing the other one. So it's attaining a higher position versus that one at the same time. So yes, I do think that one cyclist passes the other one, and I think A is going to pass B. And these are just kind of making a general sketch of what they would look like because there's no numbers on these graphs. So all you have to do is break them down into their segments and then think about each one individually. Constant speed, positive direction, medium. So, and that goes for 3 boxes. So that would mean that line would go right there. So that part's done. The middle section, there is no movement because you stay at the same position the whole time. If there's no movement, there is no speed, and that lasts for 1, 2, 3, 4, 5 boxes. So that one's going to be right there on our 0 line, of course, no speed. Don't forget your 3 dots between the two. And then our last segment is positive direction again, but it's steeper than our original one. So I would move him clear up here for the last 2 boxes and draw your 3 lines. So that's how you do it. So I'm just going to sketch in these next 2 real quick. You can see how you did. So this is what I got for my other 2 graphs. So on here we're doing the opposite. We're taking the velocity time graph and sketching what the position versus time graph would look like for that. So on here I have a positive direction. So I'm moving away from 0, and it's medium, and it's going to last for about half the time. So I'm going to go from 0 at a medium speed, constant, half the time. And then we switch directions, but we're at the same exact speed. So your steepness should be about the same, best you can, but in the other direction. So you're going to have an upside down V type of shape. So that's how you need to think about it. So I'm going to quickly sketch these next 2 and you can see how you did. So this is the general shape of what the other 2 on that page would look like. If yours are slightly different, that's okay. Just remember the main things that you need to have. You need to have relatively the same steepness, or at very least have the first segment of this one be much steeper than the second segment. And of course, these have opposite directions, so that kind of takes care of itself there. And then when you have 0 on here, which we have 3 dots up to it, and then a space and 3 dots, so that tells me the line was on 0. That means your position didn't change, so you should have a flat spot. So on here, we're doing the exact same thing we did when we cut and pasted those graphs. So you just want to take it one segment at a time. So for segment 1, to go to XI, you go to where it starts, and the position is going to be 20. For XF, you go to where it ends, this dot, and go over to the position, so that's 20. And then how much time passed. So right there is where segment 1 stops, and halfway between 30 and 60 is 45. And then here you describe your speed, which would be none. There's no movement, no speed, however you want to say it, at rest. So now we're focused on segment 2 here. So I'm going to go ahead and mark it off. So we're doing XI, which is where segment 2 starts here. Position is 20. XF, where it ends, follow it over. Position is 60. And then the time that passed, it went from 45 to 75. And so I have to subtract 75 minus 45 to give me 30 seconds. And then describe the speed, which is going to be fast, constant, positive. And then for segment 3, go ahead and mark it off like this. Go in your initial position where it starts, follow it over, it's at 60. Go to your final position where it ends, follow it over, we're going to be at 70. And then the time that passed, so from 75 to 120. And so if I subtract the 2, that was going to be 45 seconds. And now we have slow constant speed in the positive direction. So then, just like we did on our papers, we're going to take this information and transfer it over using this equation, which is the exact same equation that we use for the slope of a line that does not start at 0. Delta t is the same as tf minus ti. We just did it all in one step. So I've gone ahead and written out the work here. I filled in the equation for all 3 segments, did the work, and I came up with my answers. So now I just have to determine the units, which is going to go right here as well. So velocity is just speed, so you get the units the same way you would as speed. So find your position units, kilometers, and find your time units, which is seconds. So it's going to be kilometers per second here. So that's what all these are going to be. So now we're ready to start our velocity graph. So just go ahead and speed up the process. The first thing that I did was copy my time scale from here onto this time scale here. You can do that every time, it works really well. And then I went ahead and filled in my units because that's something people often forget to do, and I want you to remember it. Those are easy points that people just miss, so don't forget about that. So now we have to put in our speeds, 0, 1.3, and 0.2 into our velocity time graph. So we have to decide a good scale to do this with. So in order to do all of this, I would say going by 0.5s would work for you. And don't forget to fill in your negative side as well. Then you just fill it in. It went 0 over until that line right there, so you just put your constant speed on 0, just like that. Then we had a speed of 1.3, so I'm going to follow this up, and at about 1.3 I went for 2 boxes, so I'm going to go about like that, add my 3 dots. And my last one went for 0.2, so that means that it's going to drop down to here, and that lasts for 3 boxes. And just like my graph up here, there's nothing beyond the 120 mark. So that one looks good, and I just have one thing to do to finish up. What's happening during the first segment? So looking at that up there, it's flat. Position goes from 20 to 20, which means it didn't change. If my position doesn't change, that means I stood in the same spot. So the object did not move during the first segment of time. Okay? If you're able to do all of this, you'll be perfectly fine on the test. If you want to do some practice problems, take some practice problems home with you, let me know. I'll be happy to do that for you. Or if you want to study with me after school or before school, please do so.